Okay, I'm going to discuss longest increasing subsequence problem in this video. So in this problem you will be given an input array. Let's say input array consists of integers, and your task is to find the length of the longest increasing subsequence. So let's take an integer array 5, 10, 0, then let's say 3, 40. Now subsequence, let's see some subsequences from this array. So 10 and 40 is a subsequence. So subsequence need not be, so numbers don't have to be next to each other to form a subsequence, right? So 10 and 40 is a subsequence. 0, 3, 40 is another increasing subsequence, because you can see 3 is greater than 0 and 40 is greater than 3. Now our task is to find the longest among all such possible subsequences, right? So if we were to do this problem using brute force, it's going to take exponential time, which we obviously don't want. So what we are going to do is we are going to use a dynamic programming approach here, and we will be taking an extra array of the same size as input array. Yeah, so let me take another array. Let's call it as LIS. And this LIS array will be initialized to 1. So all elements in this LIS array are initially 1. Okay, so now here is the main concept that you need to understand when understanding the solution for this problem. And also in this video I am discussing the order n squared solution. Order n squared solution is not an optimal solution for this problem, but I'll be discussing n log n in a separate video. Alright, so what we are doing here is that we will be saving the length of the longest increasing subsequence ending with ith element in LIS of I. Okay, so let me write it down. So LIS of I represents length of the longest increasing subsequence that ends with input of I. Okay, so let's take an example. So let's take the 0th index. For LIS of 0, what that will have is length of the longest increasing subsequence of input of 0. Okay, so input of 0 is 5, and what is the length of the longest increasing subsequence which ends with 5? So because there are no elements before 5, the length of the longest increasing subsequence which ends with 5 will be 1, because there is only one subsequence, and that is 5, right? That ends with 5, and its length is 1. So LIS of 0 will be 1. Okay, so LIS of 0 will be 1. So all we have to do is we have to find this. We have to find at every index, we have to find the length of the longest increasing subsequence that ends with that element. Okay, so when we move on to the next element in the array, that is 10, now we have to find what is the length of the longest increasing subsequence which ends with 10. So what we do is we go to the beginning of the array and we start from the beginning and start seeing whether 10 can form a increasing subsequence with that element or not. So let's say the jth index will always start with 0, and our ith index will keep on moving till the array is completely visited. Okay, so 10 will be compared with, so we see that 5 and 10 can form a subsequence. Okay, so for index 10, there's only one element before 10 in the array, so we see that 5 can form a subsequence with 10, and the length of that subsequence will be what is the longest increasing subsequence which ends with 5 plus 1, because we are adding 10 to it. Okay, so the length of the longest increasing subsequence which ends with 5 is 1, and then because 10 we are adding 10 to it, the length of the increasing subsequence formed will be 2. So for 10 we will update it to 2. What does that mean? That means that the length of the longest increasing subsequence which ends with 10 is 2, and the example is 5 and the subsequence is 5 and 10 whose length is 2, right? Things will get clear as we move on to the next elements. So then we increment I by 1, and then I points to 0. Now we have to start from the beginning of the array again. So j starts from the first element of the input array, and we'll see if every element before 0 can it form a subsequence with 0. Okay, so we'll check 5. Can 5 form a increasing subsequence with 0? No. Can 10 form increasing subsequence with 0? No. So what does that mean? That means that there's only one increasing subsequence that ends with 0, and it's 0 itself, right? And the length of that is 1. So we will keep the length, we'll keep the alias of 2 as 1, because the length of the longest increasing subsequence that ends with 0 is 1. Let's move on to the next element. Now I moves on to the next element. Okay, it will point to 3, and we'll again start from the beginning of the array. So j equal to 0. Now we'll compare 5 with 3. 5 cannot form a subsequence with 3. Okay, so then we move on to the next element. 10, can 10 form a subsequence with 3? No. We move on to the next element. Now in case of 0, we see that 0 can form a subsequence with 3, and what will be the length of that subsequence? It will be the length of the subsequence that ends with 0 plus 1, because we are adding 3 to it, right? Okay, because we are adding 3 to it. So and that length will be 2, because out of these 3 elements before 3, only one element can form a subsequence with 3, and the length of the longest increasing subsequence which ends with that element or ends with 0 is 1. So adding 3 to that subsequence 0 comma 3, its length will be 2. So we have updated the LS array as 2. Okay, now when we move to the last element of the array, that is 40 here, I is incremented again, and I is now pointing to 40, and j, we again start with j from the beginning. So j equal to 0. We see if 5 can form a subsequence with 40. Yes, 5 can form a subsequence with 40, right? So for the first element, we see that yes, 5 can form and what will be the length of that? The length of that subsequence which ends with 40 will be 2. Okay, then we move on to the next element, 10. We see that 10 can also form a increasing subsequence with 40, right? What will be the length of that subsequence? It will be length of the longest increasing subsequence which ends with 10 plus 1. Now what is the length of the longest increasing subsequence that ends with 10? It is 2. Okay, so for first index, so it is 2 plus 1, because we are adding 40 to it, equal to 30, and the example is 5, 10, 40, right? Then we increment j again, and here we see that 0 can also form a subsequence with 40. Okay, and what will be the length of that subsequence? The length of that subsequence will be 2. Then we again increment j once, so j is pointing to 3 now, and we see that 3 can also form a subsequence with 40. What will be the length of that subsequence? The length of that subsequence will be length of the longest increasing subsequence ending with 3 plus 1, because we are adding 40 to it, and the length of the longest increasing subsequence which ends with 3 is 2. So at third index we will just say 2 plus 1 equal to 3. Okay, so there are a bunch of options, or there are a bunch of increasing subsequences that can be formed which will end with 40, right? And the length of the longest among them is 3. So we will update the value to 3. All right, so this way what we have done is we have updated the LIS array with the lengths of longest increasing subsequences ending with that index or that element from the input array, right? So just to recap again quickly, at LIS of 0 we have saved length of the longest increasing subsequence which ends with 5. At LIS of 2 we have saved the length of the longest increasing subsequence that ends with 10, and at the last element, at LIS of 4 we have saved length of the longest increasing subsequence that ends with 40, okay, which is 3. And now if we go through this array once and find the maximum element, that will be the output for this problem, right? So we just have to go through this array once and just return the max element as the length of the longest increasing subsequence. As you can see here, the number of operations. So when you look at the last element, right, so in this case there are 5 elements. For last element we had to compare 4 numbers, okay. So when we are at 5th we had to compare 4 numbers. When we were at 4th element we had to compare 3 numbers, right. At 3rd element 2 numbers, 2nd element 1 number, right. So you can see this is nothing but sum of natural numbers, okay. This is approximately n into n plus 1 upon 2, or in other words n square, right. So this will be order of n square. This comparison will be order of n square. Still definitely much better than order of 2 raised to n, right. We